Alright, and today in this video we are going to talk about parametric equations. And so to start, just so we can get the concept, let's say you are trying to model the path of a ball that is being thrown off of a building of a height of 420 feet. So you have someone standing on a building and they're trying to drop a ball straight down to the ground from a height of 420 feet. Well, this is what's called the Freefall Equation. And it is the equation that determines the height of the ball at a particular time. So maybe we'll write it this way: the height at a certain time. Alright, and so there are three things that may affect the height. The first would be gravity. And unless you go to another planet, the gravity is always going to be the same as far as how fast an object falls. And then the next thing would be the initial velocity. So this is your velocity that you use to throw the ball up first, or do you just drop it straight down? And then this third thing is the initial height of the object. The initial height. And those three things combined together will determine how high the ball is at a certain time. So let's just kind of see how this would look on our calculator. So before today, we would probably type into our calculator negative 16x squared plus 420, and we'd have to go to our menu and we would have to adjust our window so that way our height will be bigger than 7. Of course, that's not going to work. So why don't we put it be 500, and our x is time, so we know that it's not going to take a whole lot of time for this ball to fall to the ground, not even 20 seconds, but we'll just throw that in there. And we will hit enter, and we see this ball falling straight down to the ground. Now, what is the problem with this particular graph? Well, there's one major problem with it. It does not accurately reflect the real path of the ball. Remember, the ball was just dropped straight down on a vertical line. It didn't go out at an angle like this. Well, that's where parametric equations come into play. And so let's say we clear this out and we go back into our calculator, and now we're going to do something. We're going to change our calculator into a different graphing mode. We're going to say parametric. And what we'll do is we will let our x be any random number. So we're going to fix our x to be 3 or 4 or 5 or whatever you want. And that's going to guarantee that the x-coordinate that the calculator graphs is going to be x all the time. And so now the y is going to change. And so that's going to be negative 16. And now we'll use the letter t squared plus 420. And we will change our time to go to 0 to 10 seconds, although it shouldn't take 10 seconds for it to fall to the ground. And then we'll hit menu and window settings, and our x is simply x, and our y, we'll just change that once again to 500, and then we'll hit OK, and we'll hit graph, and notice now that the ball falls straight down from its initial height all the way to the ground. Now, if that was a little bit confusing for you, don't worry, I'm going to explain everything here, but I wanted to show you that parametrics basically enable you to capture the real path of the object, and it graphs an x and y position as time is going forward. So in this first example, we want to see how parametric equations work. Here we have x equals t squared minus 2, and we have y is equal to 3t, and we want our time to go from negative 3 to 1. And so basically the way this works is you have various values of time. Time is ticking, time is moving, and at each time you plug that time into the x and y parametric equations for t, and for each value of t you get an ordered pair which represents the position. So maybe we'll write it, this will be the position of the object, and this will be the time. The time is not graphed. It is running in the background. So let's go ahead and write that out. You have negative 3, negative 2, -1, 0, and 1. When you plug -3 in for these t's, well, let's just do the first one so you can see how it is, and then I'll give you the rest of them. X is equal to -3 squared minus 2 for the x, and the y is going to be 3 times -3. So -3 squared is 9, minus 2 is 7, and then the y is 9, and you can see where this is going. So when the time is -2, this is going to be 2, and this is going to be -6, and then when time is -1, it will be -1 and -3. When time is 0, you'll have -2, 0, and when time is 1, you'll have -1, +3. So now you'll go over to your graph and you'll plot these points. So over 7 and down 9, it's a point right there, and over 2 and down 6, there's a point right there, and then over 1 and down 3, there's another point right there, and then we have -2, 0, then we have -1. Oops, excuse me, I missed one. This should have been -1, -3, and then -2, 0, and then we have -1, 3. So basically, the object moves like this, and it stops there. Now we're not going to take the time to do letter B, but what you'll see when you do letter B is simply that the object would now be moving from here to about there. So that's the stopping point and that's the starting point. And basically, parametric equations enable you to capture the path of an object at a starting point and an ending point. It allows you to basically capture this object moving, and you're able to start a curve and stop a curve at various points in the curve. Okay, let's say you are given a set of parametric equations and you would like to be able to eliminate the parameter t so that you can identify exactly what the graph of this parametric curve is going to look like. Well, for that, what we want to do is we want to solve one of these two equations for the letter t, and then we want to take that and plug it into the other equation for t, thus eliminating the letter t, and then you'll have an equation with x's and y's, and the assumption is from there you will be able to determine what type of graph it is. So what you want to do is you want to identify which of these two equations is the easier one to solve for t. In this case, it looks like it's the second one, so y equals 2 minus t. So you switch things around and you get t is equal to 2 minus y. And so now you're going to take this 2 minus y and you're going to plug it into the other equation for t. So let's go ahead and do that. X equals 1 minus 2 parentheses. We're not going to write t. We're going to write 2 minus y. And then we are going to have to distribute. So don't forget, when you distribute, you need to take the negative and the 2 and distribute it to both of those terms. And so what we get is x equals 1 minus 4 plus 2y. So that's going to give us x equals -3 plus 2y. So x plus 3 equals 2y. Divide by 2 all three terms, and this will cancel. So your final answer is going to be y equals, and I'm going to make it a 1/2 x plus 3/2. And so we can identify this as a linear function with a slope of 1/2 and a y-intercept of 0, 3/2. And that's how you eliminate the parameter t for these parametric curves. All right, letter B is similar to letter A. We want to figure out which of these two equations is easier to solve for t. Looks like the second one is, so we'll write y equals 3t, and so y divided by 3 equals t. So we want to take this and plug it into the other equation for t. When we do that, we get x equals y squared over 9, that's what you get when you square y over 3, minus 2. Now at this point we can stop because hopefully we will remember that there are 4 different types of parabolas. We'll go over all 4 of these. write down. So you have 4 different types of parabolas, and the first is y equals x squared, and that is a parabola that opens up. And then you have y equals negative x squared, and that is a parabola that opens down. And then you have x equals y squared. We don't really see that very often, but that is a parabola that is opening to the right. And then you have x equals negative y squared, and that is a parabola that opens up to the left. And so then all you really need to do for these problems is identify which of these 4 parabolas that it is. And obviously you can see the x and the y squared. So what you'll write is this is a parabola that opens to the right. And that's all you need to do for this problem. Okay, for this next problem, I want you to write the words different method in your notes. Different method. That way, when you're studying for this type of problem, you will remember, oh, I don't do it the same way I did parts A and B. Here, you do not need to try to solve one of these equations for t. That's not what you want to do. What you want to do is you want to square both of these equations, both sides of both of the equations. So let's say we square this one. We'll get x squared equals 2 squared, which is 4, and we have cosine squared of t. Now, don't square the angle t. You're not squaring the angle, you're squaring the trig function cosine. So it's just 4 cosine squared t, and then the y, actually let's write it over here, the y will be y squared equals 4 sine squared of t. Now what you want to do is you want to add these 2 equations together. So you'll have x squared plus y squared equals 4 cosine squared of t plus 4 sine squared of t. And now you can factor out a 4 on the right hand side here. So you have 4 and then parentheses cosine squared t plus sine squared of t. And we recognize this hopefully from our trig unit to be equal to 1. That is a trig identity. And so now that leaves us with x squared plus y squared equals 4. Now from Algebra 2, hopefully you will remember that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k represent the center, and obviously r is your radius. So here we can recognize this as a circle with a center of 0, 0 and a radius of 2 because this is r squared. Okay, let's say you would like to write a set of parametric equations that would go from the point negative 2, 3 to the point 3, 6. And so let's just graph that. Negative 2 and 3 be here. And 3, 6, 1, 2, 3, and then 4, 5, 6 will be here. And so we want to be able to come up with a set of parametric equations that would go from this point A to this point B. Well, this is very, very easy. All you do is you say, well, my x equation is going to be the x that I start with, so that's going to be that value, negative 2, plus I'm trying to go from negative 2 up to 3. That is a space of 5, so it'll be 5t. I think you can see what the y is going to be. It's going to be, well, my starting y is 3, so that's what I'll start with, plus I'm trying to go from 3 up to 6. That is a space of 3, so 3t. And let's test this out to make sure that you're convinced that what we did was correct. So when time is 0, let's plug 0 into these 2 equations. Well, when t is 0, you simply get negative 2 for the x, and when t is 0 here, you get 3. hey, that's where it should start when time is 0. Now, when time is 1 second later, let's see what you get. Take this 1 and plug it into the same two equations. Plug 1 in there for t. You get 5 times 1 is 5 minus 2. That is 3. Take that same 1 for t and plug it into this y equation. And you get 3 plus 3, which is 6. And so we see that the object started here and ended there 1 second later. Alright, drawing a circle in parametric mode is just as easy as a line. And so let's see if we can figure this out. We have a circle that we're trying to draw with a center of -2, -4, and a radius of 2. So once again, this is very simple. All you do is your x equation is going to be the x center, the x coordinate of your center, which is -2, plus the radius of the circle, which is this number, 2 cosine of t. It will be cosine because cosine is the trig function that is associated with the x on the unit circle. So I think you can figure out what the y is going to be. It's going to be the y coordinate of the center. So that's going to be -4 plus 2 sine of t. And you're thinking, is that it? Yes, it is. All right, that's just as simple as that. And so now let's just kind of show you on the calculator a couple of things that we can do with this. Okay, here we are in our calculator, and the first thing I'm going to do is I'm going to change my calculator to be in parametric mode. So graph entry and parametric, and now I am in parametric mode. So our equations that we came up with were -2 plus 2 cosine of t. And then our y was -4 plus 2 sine of t. And if we let our angle or our time go from 0 to 6.28, well, 6.28 is 2 pi. So it should make an entire circle, which it does. So there's our circle. It's a little jagged right now, but that's okay. And we'll move this out of the way. And let's just play around with this a little bit. Let's say we wanted to only get the upper half of our circle. Then what we would do is we would hit Control G, and we would go up to the equation, and we would change this ending time to pi, which is 3.14. Why? Because pi is 180 on the unit circle, and so we only want the upper half, so we only want the portion of the circle that goes from 0 degrees to 180. So when we do that, we get the upper half. And let's see if we can do the left half. If we do the left half, well, I think you can figure out what we want. We want the upper part to the lower part of the unit circle. Well, the upper part of the unit circle is the angle pi over 2. So pi divided by 2, oops, let's get that back. We will go ahead and do that again. Pi divided by 2. And then the lower part of our circle is 270. So that's going to be 3 pi divided by 2. And that should give us the left side of the circle. Let's do one last thing. Let's say we wanted our circle to be higher, or should I say longer, than it is wider. Well, then we would just change this y radius right here. Let's say we'll make it 4. And then now we've got an ellipse as opposed to a circle. So there's lots of things you can do with these parametric equations. Okay, in this next example, we are given an equation that represents Gary's position on a horizontal line as he walks back and forth on a horizontal line at any time t. And so what we want to do here, I've got my calculator in parametric mode, and so we need to simulate a horizontal line. Let's think about a horizontal line. Horizontal line, the x is changing, but the y is not changing. So therefore, I'm going to set my y to be any arbitrary number. I'll just say 3. And my x, I will put the equation that they gave us in the problem. And it says that Gary is walking along this line between 0 and 12 seconds. So when we do that, we get a line on our screen. Let's move the equation out of the way. And so we get a line on the screen. And what we want to do is we want to see where Gary turned around. So for this, we're going to have to learn how to do something called tracing on your calculator. So you'll hit Menu, 5, and we'll do Trace Step. And what we'll do is we'll change this trace step to 0.5. What this is doing is it's making it so that each time you click your button on your calculator, the time will advance by a value of 0.5 seconds. And so now that we've got that in there, we'll go back to our trace and we'll hit Graph Trace. And now I want you to notice here a few things. This is the time that we're at. This is the position that Gary is at that time. So I would like for us to start at 0. So if I go to the left, when you go to the left, that means you're going backwards in time, not necessarily backwards on the line, but you're going backwards in time. When you go to the right, you're going forward in time. So I'm going to hit to the right. I'm going to keep hitting to the right. We see that Gary is moving to the left. He's walking left, even though I'm hitting to the right. And I want you to pay attention to the position. He's at negative 9.2 right now. Then he's at negative 9.8. Then he's at negative 9.9. And I hit to the right again, and look what happens. He is turning around. So that's your first answer, that he turns around at around 10 seconds or so. Now I'm going to go to the right. Notice my time is still increasing as I'm going to the right. And we see that Gary is moving right, and then he starts to move left. So somewhere around 10 seconds. All right, now the first time I think I said 10, I actually meant 4 seconds. So I was looking at the position. But at 4 seconds, he started to move right. And now at 10 seconds, he's starting to move back to the left. And then 12 seconds, and then he's back to the beginning. So that's how you do tracing on your calculator. In this last example, now we want to do the opposite of what we did in the last example. Instead of simulating horizontal motion, we want to simulate vertical motion. So it says we have a distress flare or just a ball or whatever, and it's shot straight up in the air and then it comes back down to the ground. So for this, we want to use that Freefall equation that we talked about at the beginning of this video. And so that's going to be the height of the object is going to be negative 16t squared, which is going to be true every time because that's gravity. And then you have the initial velocity, says that is 76, so 76t. And then we have the initial height, which they tell us that is 75. And so we won't have to take the time to do this, but if you use your calculator, you will, first and foremost, you need to be in parametric mode. And what you'll do is you will type, this equation will be your y, so you'll be y equals negative 16t squared plus 76t plus 75. Why? Because the y is changing if you're going up and down. The x is fixed, so you can pick any number you want. 3, 4, 7, it doesn't matter. You just need to see a ball going up and down on a vertical line. Now, you're going to have to adjust your time. Keep in mind that all of these problems we're going to do in parametrics are real life situations. So you don't need to go from 0 to 200 on your time. 200 seconds is more than 3 minutes. Ugh! That's too long. There's nothing that's going to be in the air for 3 minutes. So please don't put 200 seconds in for your time. That is wrong. Okay, you need to think about how long this object is going to be in the air. So if you're throwing something up and then down, normally 0 to 10 seconds is a good time. And so when you do that, you will see something that goes on your screen. It'll go up, and then it'll come back down, and it'll hit the ground. And then if you want to see where it is at various times, then you can go to your table on your calculator, and in your table you will be able to see various values of time, and the position of the object at that time. I encourage you to play around and get more comfortable with using your calculator to solve these parametric equations.